wall feels solid. Steel feels permanent. Your own hands feel real and stable. But deep inside every object around you, there is almost nothing there. The atoms that build your body, your room, the planet beneath your feet, are mostly empty space. Tiny particles move in ways that should not even be possible. Some can pass through barriers. Some can exist in multiple states at once. Some seem to communicate across impossible distances faster than logic itself can explain. And the deeper scientists looked into reality, the stranger reality became. Quantum physics did not just change science, it damaged humanity's old picture of the universe. Because at the quantum level, nature stops behaving normally. Matter acts like waves. Light behaves like particles. Observation changes outcomes. Certainty disappears. The universe becomes a place built on probabilities instead of clear answers. Modern technology exists because of these discoveries, yet most people still do not realize how disturbing the implications really are. Inside laboratories, scientists discovered behaviors so bizarre that even the greatest physicists in history struggled to accept them. Some called quantum mechanics incomplete. Others believed it revealed a hidden layer of reality beneath the visible world. And even today, after decades of research, quantum physics remains one of the most successful but unsettling theories ever created. It predicts the behavior of the universe with terrifying accuracy while still leaving behind questions nobody can fully answer. Questions about matter, questions about time, questions about consciousness, questions about whether reality exists in the way we think it does. Across this video, you are going to explore 101 quantum physics facts explained slowly and clearly, starting from the simplest ideas and moving toward concepts that completely break common sense. You will learn why atoms never actually touch each other, why particles can behave like waves, why empty space is not truly empty, and why absolute certainty may not exist anywhere in the universe. You will discover how light can act like two different things at the same time, how quantum entanglement shocked even Einstein himself, and why some experiments suggest reality behaves differently when it is being observed. Step by step, these facts will slowly pull apart the normal picture of existence that most people grow up believing. Some of these ideas sound impossible at first, yet they are supported by experiments repeated again and again by scientists around the world. This is not science fiction. This is modern physics. The phones people carry, the computers running entire civilizations, the lasers used in hospitals, and the satellites orbiting Earth all depend on quantum mechanics working exactly the way physicists predicted. The strange behavior hidden inside the quantum world is not fantasy. It is part of everyday life, even if human senses are too limited to notice it directly. As this video continues, the facts will become deeper, darker, and harder to process. Early on, the ideas may seem surprising but understandable. Then slowly the rules begin to collapse. Reality becomes less stable. Cause and effect start to blur. Particles stop acting like objects and begin acting more like possibilities. At a certain point, quantum physics stops feeling like normal science and starts feeling like a direct challenge to human intuition itself. One fact leads into another, until the universe no longer looks mechanical and predictable, but fluid, uncertain, and deeply mysterious. Some discoveries in quantum theory forced scientists to abandon centuries of assumptions about how nature works. Others opened the door to technologies that once sounded impossible. And some facts remain so controversial that physicists still argue about what they truly mean. The deeper this journey goes, the more difficult it becomes to separate reality from perception, because quantum physics is not simply about tiny particles. It is about the structure of existence itself. There is a reason people stay fascinated by quantum mechanics even when they do not fully understand the equations. Beneath all the mathematics lies a disturbing realization. Human beings evolved to survive in the visible world, not to understand the true architecture hidden underneath it. The brain expects reality to behave in stable and predictable ways because that is what helped humans survive for thousands of years. But nature does not care about human intuition. At the quantum scale, the universe follows rules that seem cold, alien, and almost impossible to visualize. Tiny particles can tunnel through solid walls. Empty space constantly produces energy fluctuations. Quantum fields vibrate invisibly across all of existence. Some interpretations even suggest multiple realities may exist simultaneously. And despite all modern advancements, nobody fully understands why quantum mechanics works so perfectly. Physicists can predict outcomes with incredible precision, but the deeper meaning behind these equations remains one of the greatest mysteries in science. By the end of this video, the world around you may not feel as stable as it once did. Ordinary objects may begin to look different. Space may no longer seem empty. Certainty may start to feel like an illusion. And the line between science and philosophy may become harder to separate. That is why this is not just a collection of random facts. This is a slow descent into the hidden layer beneath everyday reality. Some facts will sound beautiful, others will sound terrifying, but together they reveal a universe far stranger than most people ever realize. Stay until the very end, because fact 101 is not about particles or equations. It is about the biggest unanswered question of all. After everything science has discovered, nobody truly knows what reality actually is. And that single realization changes the meaning of every fact that comes before it. Welcome to the channel. If you enjoy deep ideas, mysterious science, and the hidden side of reality, subscribe now and become part of this journey. Because the deeper science looks into the universe, the less ordinary the universe becomes. Quantum physics is the study of the smallest things in the universe. Smaller than dust, smaller than cells, smaller than atoms. It looks deep inside reality itself, into a world that human eyes can never directly see. A world where tiny particles move constantly, appear and disappear, collide, vibrate, and behave in ways that completely ignore the rules people experience every day. In normal life, objects seem stable. A chair stays in one place. A ball moves in a predictable direction. Cause comes before effect. Everything feels solid and certain, but quantum physics revealed that underneath ordinary life, reality behaves very differently. The deeper scientists looked into matter, the more the universe stopped making intuitive sense. The strange part is not that the universe contains mysteries. The strange part is that these mysteries are real, measurable, and proven through experiments repeated countless times across decades of scientific research. This video moves slowly through those discoveries, one fact at a time, because quantum physics becomes impossible to follow when rushed. Each fact on its own may sound simple, sometimes even harmless, but as they connect together, they begin changing the entire picture of reality itself. That is when the true weight of quantum mechanics starts becoming clear. The facts in this video are divided into levels because the human mind needs time to adjust to ideas this unusual. The first level begins with concepts that sound surprising but still understandable. Facts about atoms, light, motion, and energy. Ideas that quietly challenge normal assumptions without fully breaking them. Then the second level moves deeper into the strange behavior discovered inside the quantum world. This is where particles stop acting like objects and begin acting more like possibilities. This is where certainty collapses and observation starts playing a role in physical outcomes. Then comes the final level where quantum physics stops feeling like ordinary science entirely. The deeper layers of reality begin looking unstable, connected, and difficult to define. Distance loses meaning. Time behaves strangely. Information starts appearing more important than matter itself. By the end, the universe no longer feels like a giant machine. It feels like something far more mysterious. And every fact builds toward that realization slowly, one step at a time. Fact 1. Every object around you is made of atoms. Your body, the air, the walls, the oceans, the stars, and every living thing are built from these tiny structures. For most of human history, people believed matter was continuous and solid. But atoms revealed that reality is built from smaller pieces assembled together like invisible structures. Fact 2. Atoms are almost completely empty space. If the nucleus inside an atom were the size of a marble placed in the center of a football stadium, the electrons would move far away near the outer edges, leaving almost the entire atom empty. What feels solid is mostly space. Fact 3. The reason objects feel solid is not because atoms physically touch each other. The electrons surrounding atoms repel one another through electromagnetic forces. Your hand never truly touches the table beneath it in the way most people imagine. Fact 4. Atoms are unimaginably small. Millions of them can fit across the width of a human hair. The world people see every day is built from structures too tiny for human senses to detect naturally. Fact 5. Inside every atom, particles move constantly. Nothing at the quantum level is perfectly still. Even in extreme cold, tiny vibrations continue. Fact 6. Ancient philosophers once guessed atoms existed without any scientific tools. Thousands of years later, modern science confirmed matter truly is built from tiny units. Fact 7. The nucleus of an atom contains most of its mass. Tiny electrons contribute very little weight compared to the dense center. Fact 8. The nucleus itself is made from even smaller particles called protons and neutrons. Then scientists discovered those particles were made from smaller particles still. Fact 9. Quantum physics revealed that reality keeps becoming smaller the deeper humans investigate it. Fact 10. Electrons do not orbit the nucleus like planets orbiting the sun. That image is only a simplified model. In reality, electrons exist more like blurry regions of probability. Fact 11. A particle at the quantum scale cannot always be described as a tiny solid object. Sometimes it behaves more like a cloud of possible locations. Fact 12. Light behaves in strange ways. Sometimes it acts like a wave spreading through space. Other times it behaves like individual particles called photons. Fact 13. For centuries, scientists argued over whether light was a wave or a particle. Quantum physics revealed it behaves like both, depending on how it is observed. Fact 14. Photons, the particles of light, have no mass, yet they still carry energy and momentum across enormous distances. Fact 15. Sunlight reaching Earth began its journey around 8 minutes earlier. Every sunrise is slightly delayed by the travel time of light. Fact 16. Energy does not flow continuously at the quantum scale. It comes in tiny packets called quanta. This discovery helped create quantum theory itself. Fact 17. The word quantum simply refers to these smallest possible units. Fact 18. Electrons can jump between energy levels inside atoms almost instantly without crossing the space in between, like ordinary objects. Fact 19. When electrons change energy levels, they absorb or release photons. That process creates light itself. Fact 20. Every color visible to human eyes corresponds to different wavelengths of light. Fact 21. Human vision only detects a tiny fraction of the electromagnetic spectrum. Most light in the universe remains invisible to human eyes. Fact 22. Radio waves, microwaves, X-rays, and gamma rays are all forms of light behaving at different energies. Fact 23. The quantum world never looks completely still because particles constantly fluctuate with energy. Fact 24. Even empty space contains activity. Tiny energy fluctuations appear in tinisphere continuously in the vacuum itself. Fact 25. Vacuum does not truly mean nothingness in quantum physics. It is filled with temporary quantum events. Fact 26. Tiny particles can appear briefly from empty space before disappearing again. Fact 27. Reality at the smallest scales behaves more like motion and interaction than stable solid objects. Fact 28. Quantum mechanics predicts these behaviors with astonishing accuracy. Experiments continue confirming the theory again and again. Fact 29. Many technologies used every day depend directly on quantum physics, including semiconductors, lasers, and modern computers. Fact 30. The modern world functions because quantum theory works, even though the deeper meaning behind it remains difficult to understand. So far, This is strange, but still understandable. Fact 31. A quantum particle can exist in multiple possible states at the same time until measured. Fact 32. This idea is called superposition, and it is one of the strangest discoveries in science. Fact 33. In ordinary life, objects appear to have fixed positions. A cup sits on the table, or it does not. But quantum particles behave differently before observation. Fact 34. Scientists discovered that particles behave like waves of probability spread across many possible outcomes. Fact 35. Only when a measurement occurs does one outcome appear. Fact 36. Before measurement, the particle does not seem fully committed to a single state. Fact 37. This behavior was not invented by philosophers. It was discovered through experiments. Fact 38. The famous double-slit experiment revealed that particles can behave like waves, interfering with themselves. Fact 39. When particles pass through two openings without observation, they create interference patterns like waves. Fact 40. But when scientists observe which opening the particle travels through, the interference pattern disappears. Fact 41. Observation changes the outcome. Fact 42. This shocked physicists because measurement itself appeared connected to physical reality. Fact 43. Even individual particles fired one at a time eventually build wave-like interference patterns. Fact 44. It almost appears as though each particle explores multiple paths simultaneously. Fact 45. Einstein disliked these conclusions deeply. Fact 46. He believed the universe should follow stable hidden rules beneath quantum uncertainty. Fact 47. Yet experiment after experiment continued supporting quantum predictions instead. Fact 48. Quantum physics does not predict exact outcomes for single events. It predicts probabilities. Fact 49. Reality at the smallest level behaves statistically rather than deterministically. Fact 50. Scientists can predict the chances of where a particle may appear, but not always the exact result beforehand. Fact 51. This uncertainty is not caused by bad measurement tools. It appears built into nature itself. Fact 52. Werner Heisenberg discovered that certain properties cannot both be known perfectly at the same time. Fact 53. The more precisely position is measured, the less precisely momentum becomes known. Fact 54. This is called the uncertainty principle. Fact 55. The uncertainty principle is not simply a technological limitation. It is part of reality itself. Fact 56. At the quantum level, certainty disappears completely. Fact 57. Particles behave less like tiny objects and more like possibilities evolving through probability. Fact 58. Quantum waves spread through many possible outcomes before collapsing into measurable results. Fact 59. Some interpretations suggest all possibilities continue existing simultaneously in separate branches of reality. Fact 60. This idea became known as the many worlds interpretation. Fact 61. According to this interpretation, reality constantly splits into different outcomes. Fact 62. Other physicists reject this idea entirely. Fact 63. Quantum theory works perfectly in experiments, even though scientists still disagree about what it truly means. Fact 64. The equations predict results accurately, but the interpretation remains debated. Fact 65. Some physicists believe particles do not possess definite properties until measured. Fact 66. Others believe hidden variables still exist somewhere beneath the equations. Fact 67. Experiments continue supporting quantum uncertainty rather than hidden certainty. Fact 68. The deeper scientists investigate, the less stable reality appears. Fact 69. Quantum behavior seems disconnected from everyday human intuition. Fact 70. The universe behaves correctly according to mathematics, even when those behaviors feel impossible to visualize. This is where physics stops feeling normal. Fact 71. Quantum entanglement may be the strangest phenomenon ever discovered. Fact 72. When two particles become entangled, their properties remain connected even across enormous distances. Fact 73. Measuring one particle instantly affects the state of the other. Fact 74. Einstein called this spooky action at a distance because it seemed absurd. Fact 75. Yet experiments repeatedly confirmed entanglement is real. Fact 76. Two entangled particles behave more like parts of one system than separate objects. Fact 77. Distance appears less important at the quantum level than humans once believed. Fact 78. Information about quantum states seems deeply connected across space. Fact 79. Entanglement may eventually power future quantum computers. Fact 80. Quantum computers use superposition and entanglement to process information differently from ordinary computers. Fact 81. Instead of simple bits holding only zeros or ones, quantum bits can exist in combinations simultaneously. Fact 82. This allows certain calculations to become vastly more powerful. Fact 83. Quantum systems are extremely delicate and difficult to maintain. Fact 84. Tiny disturbances from the environment can destroy fragile quantum states. Fact 85. The line between the quantum world and the ordinary world remains difficult to define clearly. Fact 86. Some experiments suggest time behaves differently at microscopic scales. Fact 87. In quantum mechanics, events are described through probabilities evolving over time rather than simple mechanical paths. Fact 88. Cause and effect become harder to interpret in certain quantum experiments. Fact 89. Some quantum equations work equally well whether time moves forward or backward. Fact 90. Physicists still debate what time truly is. Fact 91. Quantum field theory suggests particles are excitations within invisible fields spread throughout the universe. Fact 92. According to this view, fields may be more fundamental than particles themselves. Fact 93. Every electron in the universe emerges from the same electron field. Fact 94. Reality begins looking less like solid objects and more like interacting vibration. Fact 95. Some physicists believe information may be more fundamental than matter. Fact 96. Black hole research strengthened this idea by suggesting information cannot truly disappear. Fact 97. The universe may preserve information, even in extreme cosmic events. Fact 98. Some theories suggest space-time itself could emerge from deeper quantum relationships. Fact 99. The universe may not be built from matter first, but from information, probability, and interaction. Fact 100. The closer science moves toward the foundations of reality, the stranger existence becomes. Now reality is starting to feel unstable. Fact 101. After generations of experiments, equations, and discoveries, one truth remains unavoidable. Humanity still does not fully understand reality. Quantum mechanics predicts the behavior of the universe with extraordinary precision, yet nobody can completely explain why nature behaves this way. The equations work, the technology works, the experiments work, but the deeper meaning behind it all remains hidden somewhere beyond current understanding. The universe continues operating according to rules far older, larger, and stranger than human intuition can easily accept. Every discovery answered old questions while creating new mysteries even deeper beneath them. Reality became less solid, less certain, and less predictable the further science advanced into the quantum world. Matter dissolved into energy. Particles dissolved into probabilities. Empty space revealed hidden activity. Observation appeared connected to outcomes. Distance lost part of its meaning. Certainty collapsed into statistics. And at the center of it all stands a universe that still refuses to fully explain itself. Human beings learned enough to split atoms, build quantum technologies, and calculate the behavior of invisible particles with astonishing precision, yet the true nature of existence remains incomplete, unfinished, and mysterious. Perhaps reality is far stranger than the human brain evolved to understand. Perhaps the universe operates on levels deeper than language itself can describe. Or perhaps humanity is only standing at the very beginning of understanding what reality truly is. After all these facts, equations, experiments, and discoveries, the strangest part of quantum physics may not be the particles themselves. It may be what they reveal about reality. For centuries, humanity believed the universe worked like a giant machine, solid, predictable, stable, every cause creating a clear effect, every object existing with certainty whether someone observed it or not. But quantum physics slowly destroyed that picture. Deep beneath ordinary life, reality becomes uncertain, fluid, and difficult to define. Particles behave like waves. Matter becomes probability. Empty space refuses to stay empty. Observation appears connected to outcomes. And the closer science moves toward the foundation of existence, the less familiar existence begins to feel. Maybe reality is not as fixed as it appears. Maybe certainty is only something the human brain creates to survive daily life. At the quantum level, nature does not seem interested in behaving according to human expectation. It follows deeper rules that continue confusing even the greatest physicists in history. Rules that suggest the universe is not simply sitting there like a passive object waiting to be observed. In some strange way, observation itself may play a role in shaping outcomes. And that idea changes everything, because suddenly human beings are no longer standing outside the universe, studying it from a distance. We are inside it, part of it, connected to it. The same particles that formed ancient stars now exist inside your body. The same quantum laws shaping distant galaxies are shaping every atom around you right now. You are not separate from the universe. You are one small piece of the universe becoming aware of itself. That is why quantum physics feels different from other areas of science. It does not only explain the world, it changes the way the world feels. After learning these ideas, ordinary reality starts looking less ordinary. A wall no longer seems completely solid. Empty space no longer seems truly empty. Light no longer seems simple. Even certainty itself starts feeling fragile. And maybe that is what makes quantum physics so powerful. Not because it gives humanity all the answers, but because it reveals how many mysteries still remain unsolved. The deeper science looks into existence, the larger the unknown becomes. Every discovery opens another door into something even stranger waiting underneath. If this video made you think differently about reality, then there is so much more left to explore. The universe is far more mysterious than most people realize. And every year, science uncovers new ideas that challenge the limits of human understanding. So if you enjoy videos that explore the hidden side of reality, take a second to like this video, subscribe to the channel, and share it with someone who loves deep ideas and mind-bending science. There are many more journeys ahead, and each one goes deeper than the last. And maybe we are still at the beginning of understanding reality.